Hey everyone, so you want to learn how to use trigonometry to find the missing side of a triangle or find the missing angle in a triangle. In this tutorial, I'm going to show you some easy steps on how you can achieve that by learning 3 basic trig functions. And I'm also going to show you a really cool way to remember those 3 trig functions. Now, if this is too basic for you, then you want to challenge yourself. Click on this link up here and see some word problems in the second part of this tutorial. Otherwise, keep watching these videos and let's learn some basic trig functions. My name is Peter, grab your calculator and let's get started. There are 2 objectives in today's video. The first objective is to find the lengths of sides in a right triangle, and the second objective is to find the measures of angles in a right triangle. All of the triangles that are going to be shown in this video will be right triangles. The other important thing, all of the angles that will be measured or will be shown in this video will be in degrees. So go ahead and set your calculator in degrees, not radians. For us to find any missing side of a right triangle or any missing angle of a right triangle, we need trigonometric ratios. Trigonometric ratios have a relationship with the sides of a right triangle. So let's understand these 3 sides of a right triangle using this diagram that's given here. The first side is called adjacent. And it's called adjacent because it's right next to the given angle here. The second side is called opposite, and it's called opposite because it's right across from the given angle. The final side is called hypotenuse because it is the longest side of the right triangle. Now that we understand the 3 different sides, let's see how we can calculate our 3 trigonometric ratios. So the sine of a given angle is the ratio of the opposite side divided by the hypotenuse side. The cosine of a given angle is the ratio of the adjacent side divided by the hypotenuse side. And finally, the tangent of a given angle is the ratio of the opposite side divided by the adjacent side. Remembering these 3 trigonometric ratios, sometimes it's a bit challenging. However, there is an easy acronym for you to remember the 3 ratios, and that acronym is SOH-CAH-TOA. SOH-CAH-TOA, really easy to remember. SO stands for sine of opposite divided by hypotenuse. CAH is cosine of adjacent divided by hypotenuse, and TOA is tangent of opposite divided by adjacent. So if you can't remember these 3 ratios in this form, just remember the acronym and then you'll get the different ratios. Let's see how we can apply the 3 trigonometric functions to find the missing side of a right triangle. Later on, I'm going to do some examples to look for the missing angle in a right triangle. The first triangle here on the left side has a missing side x, but a given side here 13 and a given angle 32 degrees. Now we have to figure out which of these 3 trig functions is the one to use. So when I look at this triangle, I notice that x and 13 are the shorter sides of the triangle. That means if I'm missing the hypotenuse, I cannot use sine or cosine because those 2 trig functions require the hypotenuse. So the only remaining option is to use the tangent ratio. So I'm going to write the tangent of 32 degrees because in this ratio here, I need to plug in the angle, which is 32 degrees. And this is going to be equal to x. X is the opposite. X is across from 32 degrees, and I'm going to divide by 13. 13 is adjacent. It's right next to 32 degrees. Now, if I want to solve this equation, I need to get x alone. You get x alone by multiplying both sides by 13. So when you multiply both sides by 13, you're going to get 13 times tangent of 32 is equal to x. So the final step is to use our calculator, multiply 13 times tangent of 32, and we get 8.123, and that is equal to x. In the second triangle, we are not given the longest side, but that's what we need to look for. We're given an angle 37 degrees and we're given a side here 11. So since we're looking for the longest side, I know that we're not going to use tangent. We have to either use sine or cosine. So how do we know which one to use? If you look at 11, it's right next to 32. So if it's adjacent to 32, I'm going to use cosine. So let's go ahead and calculate. Cosine of 37 is equal to 11 divided by x. So in this example here, I need to get x alone. So what I'm going to do, I'm going to multiply x on both sides, and I'll have x times cosine of 37 equals to 11. X is not quite yet alone, so if I want x to be alone, I need to get rid of cosine of 37 by dividing it both sides. So x is going to be equal to 11 divided by cosine of 37. Again, using my calculator, I'm going to get x is equal to 13.773. Here's the next set of exercises, and these two examples, we're looking for the angles in both right triangles. But the concept is going to be the same. We need to start off by looking for which of the three trigonometric ratios we're going to use. So the triangle on the left side here, I have a side 13 and another short side 4 and a missing angle. In this right triangle, I am missing the longest side. So since I'm missing the hypotenuse, I know I'm not going to use sine and I'm not going to use cosine. So the correct function to use here is going to be tangent. So I'll start off by calculating tangent of theta is equal to 4 divided by 13. Why did I put 4 in the numerator? Because 4 is across from theta, which is going to be the opposite, and 13 is right next to theta, which makes it adjacent. So when you divide 4 divided by 13, you get 0.3076. So that number is going to be the tangent of theta, but this number here does not represent the value of that angle. So what I need to do is I need to do the inverse of tangent. So theta is going to be tangent inverse of 0.3076. Using my calculator, that inverse is going to give us an angle of 17.097 degrees. In the second triangle here, we're given a short side 6, a missing angle, and the longest side, which is 9, the hypotenuse. So since we're given the hypotenuse, I know that we're not going to use the tangent. We have to either use the sine or the cosine. So the way we narrow down is we look at the 6 and the theta. Since 6 is next to the angle, we know that this is adjacent. So I need to use the cosine ratio. To start off, I'm going to find the cosine of theta is equal to 6 divided by 9. 6 is in the numerator because that's what's adjacent, and 9 is in the denominator because that is the hypotenuse. So when you divide 6 divided by 9, you get 0.6667. To find the angle of theta, we need to find the inverse of cosine. Cosine inverse of 0.6667, and I'm going to use my calculator, and that's going to give me 48.189, and that's going to be the angle that's missing in that triangle. Alright, here's the pro tip. Before you start doing any calculations, you need to identify which trig function applies to the math problem. Remember, opposite side is always across from the given angle. Adjacent side is always next to the angle, and hypotenuse is always the longest side in a right triangle, and that's the pro tip. So here's some independent exercises for you to try on your own. On the left side here, you have a right triangle where you need to find the missing side, and on the right side you have a right triangle where you need to find the missing angle. If you don't remember how to use the concepts that we learned in this video, you can always go backwards, watch the video again, and then try answering the two questions. The answers to both exercises are in the description below. Good luck!